In this demo, we'll use generative AI to help cover tracks. Okay, to start my demo, I'm on my Kali Linux box. Now, Kali comes with SSH pre-installed, so that's the client and server. Later on, we'll use a secure shell client on a Windows 11 machine to remote into this Kali Linux machine. Now, if the secure shell service isn't started on the Kali Linux box, you can type sudo systemctl status instead of start SSH. So that's sudo systemctl status SSH. And the response clearly shows that secure shell server is active and running. Okay, with that established, let's go over to my Windows 11 machine where I have Visual Studio Code open. I have a Python script named covertracks.py opened, and I have a text file named device-info.txt open. Now this is just the device information for the Kali box, and I'm going to send this to GPT-4 later on. I just got this information by typing the command that's listed on the first line, cat/etc/os-release. Okay, let's go over to this script. Starting on line 1, we're importing the modules we need. Then on line 5, we initialize the OpenAI client. And recall, it's going to be looking for an environment variable named OpenAI_API_key. So you should already have that environment variable set up on your machine. Then on line 8, I define the read device info function that's going to read the device info from a file on the local file system, and that's the device-info.txt file that I mentioned earlier. Starting on line 12, this is where we start the chat session with GPT-4. And here we've got typical parameters, and the model we're specifying is GPT-4. And we're returning response and previous messages because we want to maintain both in order to implement the multi-turn conversation. Now on line 24, the print analysis function essentially just prints the response that we get from GPT-4. Then starting on line 29, this is where we implement the multi-turn conversation. And on line 31, when we invoke the script, if we fail to include both the script and the device info arguments, then we'll print a reminder message to the user and then exit. Okay, then on line 35, we get the device info from the file on the local file system. And now the initial prompt. This is important. So here I'm specifying, how can I rotate and completely clear out all systemd journal logs, including the most recent entries on my Debian-based Linux system? And the reason that I want to do this is because we're going to secure shell, or SSH, into the Kali Linux system, and we want to cover our tracks. We don't want there to be a record of us having secure shelled into the machine. So we're going to clear out the systemd journal logs, and we're not going to delete them. Yes, we can force a physical deletion from the file system, but most intrusion detection systems with file integrity monitoring would pick that up immediately. Okay, then starting on line 40, we initialize the previous messages list by telling GPT-4 that it's a master cybersecurity analyst and researcher. Then we pass the initial prompt and the device info. Then on line 46, we make the call to start chat session. We pass the previous messages. Then we print the analysis. We set up the multi-turn conversation on line 50, and this will allow whoever's using the script to provide follow-up questions until they're satisfied, and then they can type exit and exit the program. Okay, now down on my taskbar, I'll select the terminal icon to bring the terminal up. I have PowerShell 7 open with 2 tabs. Now on the first tab, I'm going to SSH into the Kali box. And I do that by typing SSH Kali, that's the user, @ and the IP address for my Kali Linux machine is 192.168.100.130. Pressing enter, I'll specify the password, and success. We've SSH'd into the Kali Linux machine. Okay, now over on the second tab, I'll run the cover tracks Python script. So I'll start typing Python. Now I'll right arrow key to autocomplete because I've already issued this command before, and it's in the command line history for PowerShell. But essentially, you just type Python, the name of the script, and the device-info.txt file on the local file system. Then press enter. Okay, and it comes back with everything that we need. So it tells us that we need to open the terminal, use the command sudo journalctl --rotate, and then sudo journalctl --vacuum time equals 1 second. And this will delete all log files older than 1 second. And the reason why we have to rotate is because we're going to force log rotation. Otherwise, the active log would still exist, so it would show the SSH entries in the log. Okay, so let's go back over to the Kali tab. First, we'll use journalctl to see if there are any SSH entries in the journal log. And for that, I'll type sudo journalctl-u ssh, enter my Kali password. And lo and behold, there are several entries related to SSH. Okay, so we want to cover our tracks. We want to remove these. So first what we'll do is we'll rotate the journal logs. So for that, I'll type sudo journalctl-rotate, and now we'll eliminate everything in the logs older than 1 second. Sudo journalctl-vacuum-time equals 1s for 1 second. Press enter. All right, and it responds by telling us that there are archived journals that were deleted. Now let's do that same journalctl command with the -u option and specify SSH and success. So there are no entries any longer in the journal logs. Now let's say at this point we want to escalate privileges. Well, this is why we have the multi-turn conversation, because now I'm going to ask GPT-4 if less is a SUID binary that we can exploit for privilege escalation. So let's go back over to the tab running the Python script, scroll down to the bottom where it says your follow-up question. I'll type on the same system is less SUID binary that can be exploited for privilege escalation. Okay, and it comes back with information indicating that it's not very likely that less is actually an SUID binary that's set up so that we can exploit it on the system. It provides us with some useful information, including a command that we can use to confirm the permissions for the less utility. Okay, so you know what that means. Let's go back over to the Kali machine, and this time I'll type ls-l backtick which less backtick and press enter. Okay, and according to the instructions that we were provided by GPT-4, it doesn't appear that the SBIT is set. Okay, now with the exploit, the SUID binary exploit, it typically involves a situation where, for example, the less command has been mistakenly given SUID permissions, and that means that it can be executed with root privileges. We can exploit this to launch a shell if it's set up in such a way. So we'll then have a shell with root privileges. Okay, so in spite of what GPT-4 told us, let's try it. So I'll type sudo less/etc/passwd. Okay, and less brings up the passwd file. Now I'll just type exclamation sh, and this may get us a shell if this is an SUID binary. And it appears to have worked. Now if I type who am I, the response is root. So we've also successfully elevated to root privileges on this machine. Okay, well with that, we've successfully used generative AI to help cover tracks. In this demo, we'll use generative AI to identify signs of track covering activities. To start my demo, I'm on my Windows 11 machine, and I've got Visual Studio Code open with a Python script named audit accesslogs.py, and I also have another file, access.log, open. Now, down on the toolbar, I'll select the terminal icon to bring up PowerShell. I have PowerShell open with 2 tabs. On the first tab, I've SSH'd into a remote Kali Linux machine. Kali comes with Apache 2 web server pre-installed, and accordingly, it stores Apache 2 logs on the local file system. Okay, so first I'll just elevate privileges to root privileges by typing sudo -i Kali password. Now cd to var log Apache 2. Now if I do an ls, I have a couple of log files. We're interested in access.log. Now if I do an ll on access.log, it's a pretty big file. Now let's do a line count. For that, I'll type wc-l access.log. Okay, so there's approximately 2.3 million lines in the access.log file. So this is huge. And it's hard for humans to sift through all the access.log entries line by line. Each line in the log represents a single request made to the server. And each line has a number of different columns that provide valuable data for analyzing web traffic, troubleshooting issues, and detecting malicious traffic. You see, sophisticated hackers will often try to blend their malicious activities with legitimate traffic in an attempt to avoid detection. They may perform common operations like hitting standard web pages, using different user agents, distributing their requests over time, and even from various IP addresses. Therefore, it's important to have robust security analytics, tools, and skills in place that can detect and interpret suspicious activities, even if they are masked as legitimate requests. And that's exactly what we'll do using GPT-4 in this demo. Okay, back over to Visual Studio Code. So for my Python script, starting on line 1, we import the modules we need, then we initialize the OpenAI client, then we define a function, read access logs, and this is going to read the access logs from a file on the local file system. On line 12, we start the chat session, and this is going to be a multi-turn conversation, so if we want to ask follow-up questions, we'll be able to do so. Notice the model on line 17 is GPT-4. Then we print the analysis using the print analysis function. That's on line 24. Then starting on line 29, we implement the multi-turn conversation. Now the important part that I'd like to highlight here starts on line 36. This is the initial prompt. So I'm telling GPT-4 that here's some access log data from an Apache 2 log. Please review this and generate a report of any potential entries in the log that may indicate hackers trying to infiltrate our network. For the report, please give me a formatted report with headings and make it look professional. So that's pretty self-explanatory. Okay, so now let's explore the access log. All right, now this access log doesn't have 2.3 million rows, but these lines alone will give us an accurate understanding of how GPT-4 can sift through multiple lines and detect some potentially malicious activity. Okay, just quickly going over the columns. First we have the client IP address, then we have the remote log name, and this is typically represented by a hyphen because in most configurations it's rarely used. Then we have the authenticated user. If no user is authenticated, then it's represented by a hyphen. Then we have the date and time of the request. Then we have the request line from the client, and this is the actual request line from the client, including the method, GET or POST, for example, the resource requested, and the protocol version. It includes a status code, the size of the response, the referrer, which is the URL of the referring document if there is one, otherwise it's represented by a hyphen. Then there's the user agent, and the user agent string of the client identifies the client's browser, the operating system, and some other details. So I know there's at least a couple of entries here that are suspicious. For example, look at line 13. Get admin panel hidden settings. And then just below that, on lines 17 and 18, we have two instances of get confidential data-export.php. Now, even though these requests resulted in 404 not found and 403 forbidden responses, it does indicate that someone may be probing for sensitive or hidden directories which might contain confidential data. Now imagine we had the 2.3 million lines from the access.log file that we saw over on the web server. It would be virtually impossible for us to go through the entries line by line to find potentially suspicious activity interspersed amongst the 2.3 million requests. Let's run the audit access log script. So we'll go back to terminal, I'll select the second tab in PowerShell, and now to run the script, I'll type Python, I'll right arrow to autocomplete. But basically, I would just start typing audit access logs and autocomplete, and then start typing access.log and autocomplete that. So Python audit-access-logs.py and access.log. Pressing enter. And GPT-4 comes back with our cybersecurity report, and it provides us a comprehensive analysis of potentially malicious activities. So the first entry of interest tells us that the logs indicate a delete method from a specific IP address on an API, and a return to 404 status indicating the requested resource doesn't exist. It also tells us that the user agent is CORL, and this is a command line tool used from the terminal. It possibly indicates a hacking attempt. Then the second interesting entry shows a GET request to access the WordPress login page. Then, as we noticed earlier, the third entry has a GET request for admin panel hidden settings.php, and although again it returned a 404 status code, it could suggest that the user was trying to access potentially sensitive or restricted information. Then, listed as number 4, GPT-4 recognized that there are both a GET and a POST request within a very short interval to the WordPress login page. And this is an indicator of potential password brute force attack. And listed as number 5, this entry unfortunately was cut off due to my limitation for max tokens. I had it set at 500. If I wanted, I could expand it to 1,000 tokens and this report would complete. Nevertheless, this is good. And this entry actually indicates the entry that we noticed earlier where there's a GET request for confidential/data-export.php. And this again could indicate that someone is probing for sensitive or hidden data. So overall, GPT-4 was able to sift through the access log and point out some interesting entries. At this point, it's important that we investigate the logs further. This could involve correlating these requests with other logs for suspicious activities, reviewing web app security settings and access controls, and monitoring for repeated or similar access patterns from these IPs or user agents, and any other tasks as required. It's important to keep in mind that logs often provide initial clues, and continuous monitoring and analysis are key to maintaining network security. With that, we've successfully used generative AI to identify signs of track covering activities.